Hey all, welcome to Homeschool, and this is part 13 of the chapter Light, Reflection and Refraction. So 11 parts are over on a chapter where all the concepts have been completed so far, the previous concepts. If you want to watch them, click the link that is provided in the description. Enjoy the concepts in a detailed way and in a very beautiful way. And coming to the today's concept, the most important concept of this chapter, I can say, all the concepts are important, but important of the important. Okay, so that is image formation by convex lens, or how do we predict the image? By drawing the ray diagrams, isn't it? So let us try to draw the ray diagrams one by one. Here we will have 6 cases. Like, can we compare the cases of concave mirror here? See, here actually the ray diagrams are similar to concave mirror. If you can remember the ray diagrams of concave mirror, it is very easy. So let me try to compare all the cases with the cases of the concave mirror, right? See, if you can remember the very first case, what was the case? If the object position was at infinity, where was the image formed in case of concave mirror? I'm talking about mirror. I have not yet started the lenses. I'm just revising about the mirror's case. Okay, so when we keep the object very far at the infinity, do you remember our image will form at focus? Right? And the nature of the image in case of concave, the image is always real and inverted, isn't it? And the size is very much diminished. Size is very much diminished, or we said it as point size. Okay, if you can remember the concave mirror ray diagrams, this is nothing. This will become very easy. That's why I'm trying to compare each and every case with mirror, and then I'll start. Okay. So case number 1. So case number 1 is object is at infinity. Object at infinity. Say in case of mirror, when the object at infinity, image has formed at the focus, right? Now let us see what happens here. So let me draw a convex lens here, and this is center of a lens, that is optical center we call, and the principal axis where this is our f1. This is actually center of curvature. We can also call it as 2f2, right? And this is 2f1. This is f2 and this is 2f2, isn't it? So I will use any 2 rules here. The rules that we have studied in the previous video will help us now. Okay, we have to draw any 2 rays. Compulsorily 2 rays is minimum, because 2 rays are required, no, to find out where refraction occurred, like where refracted rays have met. Because keep one point in our mind, guys. In case of mirror, image is formed wherever refracted rays, 2 refracted rays met. Here, image is formed at a point where refracted rays meet. Okay, for a meeting of refracted rays, 2 incident rays you have to draw, right? So you have studied 3 rules for drawing ray diagrams of convex lens and 3 rules for drawing ray diagrams of concave lens. So any of the 2 rules you can use it here. Okay, so let me use the first rule, that is, if the incident ray is parallel to the principal axis, what happens? The refracted ray will pass through what, guys? Focus, principal focus, right? And let me consider another incident ray which is parallel to the principal axis, because object is kept at infinity. When the object is very far away, whatever the rays come out from that particular object, they will remain. I mean, they are called incident rays. They are almost parallel to the principal axis only. Almost all the rays will remain parallel to the principal axis. So another incident ray also I considered being parallel to the principal axis. So even this particular ray will pass through focus. So where is the image formed, guys? Image is formed at focus, right? Which focus? F1 or F2? Two focus points are there. You have to specifically mention. It is formed at F2. That means wherever refracted rays are there, that side only image is formed, that too at focus. Okay, that means, you know what I will write? If the object position is infinity, this was in case of mirror. But here also image is formed at focus only, but two focuses are there. No, you have to specify whether F1 or F2. Image is formed at F2, right? Let me write here also image position. Image position is what, guys? F2. It is formed at focus. And what is the nature of image? Nature of image is real and inverted only. It is real and inverted. Okay, because you know, wherever converging takes place, that side if image is formed, like it will remain as a real image. Okay, and real images are always inverted. And what is the size of the image? Size is point sized. Point sized, or you can also say it as highly diminished. Okay, I will call point size as highly diminished, right? So this is the first case. See, in case of mirror it was at focus. Here also it is at focus only. But which focus? F2, definitely. Okay, fine. Because it's a convex lens, you know, at this focus the refracted rays are meeting, right? So F2. Nature of image is real and inverted. So case 1 is over. Now coming to case 2. Do you remember the case 2 in case of mirror? Right? So in case of mirror, when we bring object near to the mirror, near in the sense from infinity you are bringing, where you are bringing beyond C, right? Beyond center of curvature, when you brought the object, where was the image formed? Image was actually formed between F and C, focus and center of curvature, right? And the nature of image was real and inverted. Nature of image was real and inverted, and here also the size is diminished. We are comparing. This was the case, second case of mirror. Here also I am bringing object beyond center of curvature. That means here center of curvature is this, right? So beyond 2F1 I will bring the object. Okay, so beyond instead of C. This was in case of mirror. I am comparing, guys. So here what is the position of the image, object? It is, I am bringing the object behind 2F1. So let me draw the ray diagram. This is optical center. Drawing ray diagram is very, very important, guys. This can be asked in the examination, but you have to use the scale and draw it properly. I am just doing a rough one here. Okay, so this is F1 and this is 2F1 and this is F2. This is 2F2, right? And I have kept my image here. Okay, AB is my image. Okay, I kept behind, behind 2F1. And I will use any two rules, okay, for drawing a ray diagram. First one is the ray which is, parallel to the principal axis. Where will the refracted ray go? Refracted ray moves, through the focus. It will move through F2. And now I will take actually, another incident ray through O. And where will it go? It will go like this, right? Say arrow mark, showing an arrow mark is very important, guys. So this first incident ray was parallel to the principal axis. And where did it go? It passed through the focus, right? And second incident ray, I passed it through optical center, and you don't observe any refraction here. It goes in a straight line. Actually, you have to draw perfectly straight line. Okay, mine is little curved, but you have to draw perfectly a straight line. So where are these two refracted rays met? Here they have met, right? So here they have met, and what image is formed here? Real and inverted from the principal axis. If you draw the arrow mark, something like this. See, image was like this, AB, and here the image is inverted. That means A is on a principal axis, B is down, inverted image. Okay, so this is our second ray diagram. Let us write. So where is image position? Image position is, between, it is between F2 and 2F2, right? So 2F2 is nothing but center of curvature. And what is the nature of image? Nature of image is real and inverted. Real and inverted. And size of the image, can you tell me? It is also diminished only. Yes or no? Not very much diminished, slightly diminished. Clear? So this is our second ray diagram. So let me make changes here. So it is, object is kept beyond 2F1. Okay. So where is my image as formed? Image as formed between F2 and 2F2. And then these things are same. Nature is real inverted, size is diminished. See how similar it is with the concave mirror, right? That's why I am comparing here. Coming to the third case here, case 3. So case 3, do you remember the case 3 of concave mirror? When object was kept at C, right? Image also formed at C. And here the nature is real inverted, and here size of the image is same size. Yes or no? Now let us see what happens. Here object, I will keep it at C only, but two C's are there, right? This is one C, this is another C. This C we call it as 2F1, this C we call it as 2F2. We keep object here in front of the lens. Okay, fine. So object at 2F1. So let us see what happens if I keep the object at 2F1. So instead of C, what I will take, object is at 2F1. So this is our lens with optical center O, right? And this is 2F1, this is F1, this is F2, this is 2F2, right? Fine. And where did I keep my object? Exactly here. Okay, here I kept my object. And let us see what happens. Okay, any two rules you can use here. First one, if a ray is parallel to the principal axis, it will pass through focus. And if a ray is passed through O, that is optical center, there is no refraction, right? It will pass straight. It will pass straight. So where are they meeting, guys? Exactly here they are meeting, right? So how is the image formed? Inverted image. Here they are meeting. So inverted image is formed. So where is image position here? Image position. Image position is at 2F2, right? See, another C. See, if the object was at C, image formed at C only. In case of mirror, object kept C at this side, image is formed C at this side. That is 2F2, right? So instead of C, what I will write? 2F2. And what is the nature? Nature is real and inverted. Real and inverted, right? And what is the size? Size remains same, guys. Okay, you will get same size. Since I am drawing a rough diagram, my size here would have looked a little bigger than this, but you get same sized image here. So when you draw it with measurements, with scale and pencil, you will get image of the same size actually. Clear? Fine. So these are the three cases. Let me erase and show you the next three cases. Till then, quickly you can take a screenshot or a photo. Okay. Coming to case 4, guys. Do you remember case 4 of concave mirror? See, case 4 of concave mirror, object was kept between C and F. Object was kept between C and F, and image was formed beyond C. Image was formed beyond C. Yes or no? So here the nature is real and inverted, and actually here the size is little enlarged. So this was the case of concave mirror. Now let us see what is the case for of convex lens. Okay, say if this is our convex lens, you have to draw along with me so that it becomes easy. I'm telling you again and again. Okay, this is F1, this is 2F1, right? And this is F2, and this is 2F2. Clear? And where am I keeping my object here? I am keeping, see, in case 4 of mirror, it was kept at C and F. This is C now for us, this is F. So between 2F and F1, I am keeping my object. Okay, so what is, instead of C, what I can write? 2F1 here. Okay, and here instead of F, what I can write? F1. Let me see where is my image formed. Okay, use any two rules. So incident ray, which is parallel to the principal axis, always passes through focus, right? And the next one is an incident ray, always show with the arrow mark, guys. Even if I forget, you have to show the arrow marks in your books. When you don't show the arrow marks, no marks will get cut. So this is a refracted ray, arrow mark. And a second incident ray, I am passing it through optical center. So no refraction here, it passes in a straight line, right? Say in this direction. So where are these two refracted rays met? These two refracted rays met at this point, right? That means, see, behind 2F1. This is also like center of curvature on the other side, right? So what I can write? Where is the image formed? Behind C. C in the sense what? See there. 2F2. 2F2 is also a center of curvature, but on the other side. That's it. Okay. So let us write down also. So image position is beyond. Okay. It is beyond or behind 2F2. Okay. And nature of image is definitely image is formed in the same side where refracted rays are there. So it is a real image. Real images are always inverted. You can see, right? It is inverted. Fine. And what is the size? From here you will get enlarged. As the object goes near to the lens, the images that you get will be enlarged. This is what we have seen in case of mirror also, right? It's not a new thing for us. Fine. And coming to, case 5. Case 5. Do you remember case 5 of the mirror, concave mirror? Case 5 was object was kept at focus. When object was kept at focus, image was formed at infinity, right? So now let us see what happens here. Here, where do I keep my object? Let me keep my object at focus, this focus, okay? That is at F1 if I keep, let us see where is image formed. So this is O optical center, and this is our F1, okay? And this is 2F1, this is F2, this is 2F2. Yeah, okay. So where am I keeping my object? I am keeping my object here, guys. Okay, and let us see what happens. So I'll draw one incident ray parallel to the principal axis. So refracted ray will pass through what? Focus. Okay, F2. And another incident ray I will take through optical center. Okay, no refraction occurs. It goes in a straight line. Okay, where are they meeting, guys? You see, two rays are actually parallel to each other. During mirror's time, I told you, the parallel rays, somewhere at some point they will meet. Okay, imagine they go and they met at this point. So what happens? This much big image is formed. Parallel rays do meet at certain points, somewhere very far. So you get a very enlarged real inverted image you will get. Okay, so what I can write here, instead of F, I can write F1. Okay, object position at F1. So image is formed at infinity, yes, and nature is real and inverted. Nature is real and inverted, and here also enlarged image you will get. Okay, again I'm not writing the points there, I have written it off here. So carefully you separately write the points in your book. Okay, relating to object position is here, image position is infinity. Okay, let me write it off. Image position is at infinity. What is the nature? Nature is real and inverted, and size is, enlarged. Okay, so this is our case 5. And coming to the case 6, which is very, 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 very important. Okay, so in case of mirror, do you remember what was our case 6? Object was kept between focus and pole, right? Center of the mirror was called as pole in case of mirror. And where is image formed? Image is formed beyond mirror. Yes or no? Beyond mirror. Here you actually got virtual image. Virtual and erect image you got, and and the image was enlarged. You also got enlarged image. Now let us see what happens here. Let me take the case 6 here. Okay, if this is our convex lens, this is O, and this is F1. Okay, this is 2F1, this is F2, this is 2F2. Clear? So where am I keeping my object? Between, see, in case of mirror it was between focus and pole, right? Here it is between F1 and O, optical center, instead of pole, which is the center of lens, O, right? So here I am keeping my object. Okay, and let us see where is image getting formed. So I'm keeping object at object, I'm keeping between F1 and O, guys. This is the condition. This is the case 6, last case, very, very important case. Okay, and I'm using the first rule. First 2 rules I will use. See, this is the first incident ray parallel to the principal axis. Okay, and it will pass through focus like this. Right? Say this is incident ray and this is my refracted ray passed through focus. And second one is, let me draw an incident ray passing through O. How does it go? It will go like this. There is no connection only, they are not even parallel, guys. This ray is going like this, right? This ray is going down actually, right? Say, actually, where are they meeting then? Say the refracted rays are not meeting this side, guys. Okay, if they are not meeting, they will meet the other side if you project them. Okay, if I project the refracted rays, okay, the second refracted ray, that is an incident ray passed through the optical center, no, that I am dragging this side. I'm just other side, whether they are meeting or not, I'm checking. Okay, and this refracted ray I will project. I mean projecting in the sense I'm dragging backside. So where are they meeting? They are meeting backside, guys. Say they are meeting like this, right? And you see virtual image. Refracted rays are this side, but the image is forming the other side. The other side, if the image is formed, that is called virtual image. And you see the image is erect. See, arrow mark upright. The image that you got for the arrow mark is upright only, right? So definitely this is a very important case. So where is the position of the image? Position of the image is same side of the object. Okay, position of the image is same side of object. Yes or no? Object is this side, and the same side you got your image. So same side of the object. So what I will write here? Same side. same side of object. Okay, and the nature is virtual and direct. Image is slightly enlarged image you got. Okay, so these are the remaining 3 ray diagrams. Altogether 6 ray diagrams. So you can take a photo or a screenshot of this, okay, and learn all the 6 ray diagrams with practice. And this particular chart is very, very important. Okay, see, I have purposefully compared each and every case with concave mirror because it's almost similar. Only the terms, instead of center of curvature, you will have 2f1 and 2f2, something like that, right? So this particular table is very, very important to remember, and drawing a ray diagram is also important. Okay, so these are the ray diagrams of convex lens. Now let us go for the ray diagrams of concave lens. Only 2 cases are possible here. Let us discuss the 2 cases. Coming to the ray diagrams of a concave lens, it is almost similar to convex mirror, guys. Okay, convex mirror, do you remember? Only 2 cases were possible. One was when you keep the object at infinity, you got image at focus. It was virtual and erect image. Okay, and second case was when you keep the object near to the mirror, you know, where did you get your image? You got a virtual image, and it was between the focus and pole, isn't it? Say similarly, let us see what are the 2 cases here. Say, let me draw the ray diagram of case 1. Here also object I am keeping at infinity. Okay, so let me draw our concave mirror, and this is our optical center O, right? And this is like f1, and this is 2f1, right? And this is f2, and this is 2f2. Okay, so where am I keeping my object? Object I am keeping far away at infinity. Okay, so at infinity, whatever incident rays come, they are actually parallel to the principal axis, right? They are parallel to the principal axis. But the incident rays in case of concave mirror, they won't pass through focus directly, right? They converge like this, they go away, right? Even this goes like this, right? But when you project these lines, I mean when you retrace these lines, when you drag these lines on the back side, it appears that they have passed through what, guys? They have passed through focus, right? So where are these refracted rays now met? It is met at focus. Which focus? F1 or F2? They won't meet at F2, they will meet at F1, the other side. That's why you are getting a virtual image. Okay, so where is the image forming? First let us fill this. Where is the object position? Object position is at infinity. And image position, where is image position? Image position is at F1, that is at focus. What is the nature of image? It is virtual. It is virtual and erect. Okay, and what is the size of the image, guys? Size is point sized, highly diminished. Point size, or we can also say highly diminished. HD in the sense highly diminished. Okay, so these are the characters of image. And coming to case 2. In case 2, object is kept near the lens. Near the lens. That means anywhere. You can keep object at 2f1, behind 2f1. You can keep at f1 or anywhere. Okay, near the lens I am keeping my object. So carefully observe here. This is my optical center O. This is our principal axis. And here is our f1. And this is our 2f1. This is our f2. This is our 2f2. Okay, where am I keeping my object? Okay, let me think that, okay, I'm keeping my object here. I'm keeping my object here. Okay, say I'll use any 2 rules, right, to draw the ray diagram. Say I'm using the incident ray parallel to the principal axis. Okay, and what happens? It deflects like this. and another incident ray I will take through optical center. See, it is not straight, right? Let me draw once again. An incident ray passing through optical center, there is no refraction, right? It will pass straight. Okay, and now it's like, say this side they are not meeting, so try back side. Say this is your straight line, right? That is the incident ray passing through optical center. It doesn't show any refraction. Okay, and you drag this line. This is a refracted ray, right? You drag line, show its direction backwards. Where are they meeting? Where are they meeting? Here they are meeting, right? When you drag, when you project this refracted ray, here both rays are meeting actually. So here. So where is the image formed? Here, between focus and optical center. Okay. So here our image is forming. So where are you keeping your object? Near the lens. Any position near the lens when you keep, image is formed between F1 and O, that is optical center. So here also virtual, the image is formed on the same side as that of object. Then in that case, virtual and direct image only is formed. Okay, and the size is diminished, not very large. You see, the size of the object is this much, size of the image is only this much, right? In that case, we call diminished. So these are the two cases, the two ray diagrams of our concave lens. Okay, so 2 cases for concave lens and 6 cases for convex lens. So you can take a picture or a screenshot, very, very important. Okay, you must carefully know how to draw the ray diagrams. Draw it with scale, it will come neatly. But practicing a ray diagram is very important. Until and unless you practice this, it will not come. So you should continuously work on this, right? It's very easy. Only thing is you should work, then you get that perfection. Clear? With this, I complete the video, and let us meet up in the next video where we will discuss the sign convention of lenses, lens formula. In case of mirror, we discussed mirror formula, no? Same way here, lens formula and magnification. After that, we will see few numericals. So we are at the end of the chapter almost. So we can complete the chapter maybe in 2 to 3 videos maximum, right? So do subscribe our channel to learn the concepts in the easiest way and in a detailed way. Thank you so much.